I being asked by evolutionists, if you think Darwinian evolution is wrong, then how do you explain the speciation of, for example, wolves, foxes, and dogs, such as the Great Dane and the Chihuahua? Well, to answer that question, we actually have to address what is actually Darwinian evolution. Darwinian evolution is the belief that populations adapt to environmental pressures through the natural selection of blind variations. It also is the belief that species can become into new species once genetic information is added. This increase of genetic information is believed to be caused by the random mutations during natural selection. Basically, Darwinian evolutionists use microevolution and macroevolution to distinguish the evolutionary changes. Macroevolution is the concept of genetic changes within the species level or below the species level, while macroevolution is the process where species become into new species. In other words, that they cannot reproduce to each other. By using this logic, we can conclude that reproductive isolation and adaptation is the result of evolution. However, evolution holds two things. One is that natural forces such as natural selection are uniform forces, and that random mutations occur to create new species. And two, evolution holds the assumption that populations adapt to environmental pressures through the natural selection of blind variations and random mutations. If more fur, for example, is needed and some individuals accidentally are endowed with mutations that confer a thicker coat of fur, then those individuals will have greater survival and reproduction rates. The thicker fur mutation will then become common in the population. This is the evolutionary notion of change. If those two assumptions are violated, then adaptation and reproductive isolation cannot be considered evolution. So, does Darwinian evolution really stand up to the hype? Not really. What we call speciation of two or more different species is actually the result of allopatric speciation. Allopatric speciation is when species subdivide into two or more subpopulations through geographical barriers or reproductive isolation. Those two separate populations may evolve distinctly different characteristics. If the geographical barriers are later removed, or the isolation barriers, members of the two populations may be unable to successfully mate with each other, at which point the genetically isolated groups have emerged as different species. Allopatric isolation is a key factor in speciation and a common process by which new species arise. The difference between allopatric speciation and Darwinian evolution is that allopatric speciation relies in environmental pressures, while Darwinian evolution relies in the uniform process of uniform natural selection and random mutations that create new alleles within certain population of the same species. However, considering that allopatric speciation responds to geographical and environmental factors, it is quite reasonable to say that these changes are the result of epigenetics rather than Darwinian evolution. Both allopatric speciation and epigenetics explain very well how speciation in species occur. However, such variation is limited in the basis of their own kind. For example, fishes will always remain various species of fishes. Horses will always remain various species of horses. Birds will always remain various species of birds. And reptiles will always remain various species of reptiles, and so on. This notion actually explains very well why we see variations of species, because it is quite possible that those variation of species have actually subdivided from subpopulations that were geographically isolated as well as reproductively isolated to create brand new species. This is the result of epigenetics rather than evolution, because evolution relies in populations creating new alleles by natural selection and random mutations. However, considering now that allopatric speciation, we can now infer that these changes are the result of environmental and geographical factors. So, if Darwinian evolution is not true, then where do for example, foxes, wolves, and coyotes come from? Well, that is really simple. What you call dogs, wolves, foxes, and coyotes, they're actually from allopatric speciation. They actually subdivided into new species from different from different geographical locations and reproductive isolation factors. If this theory was true, then that will mean that all those animals have something in common. What is that common? Well, that common is actually the genus of canine. When the earliest species of canines first arrived in nature, they actually subdivided into brand new species from subpopulations that were geographically isolated or reproductively isolated from each other. This eventually created new species of canines. This actually results in wolves, foxes, and coyotes, and even dogs, because they all share a common genus, and that genus subdivides into new species. This is actually how variation in the animals that we see works. It has nothing to do with Darwinian evolution, because Darwinian evolution suggests that populations create new alleles by the process of natural selection and random mutations. But we all know that that is not the case, because we know that environmental pressures actually responded to the creation of new species. However, the fact remains, canines will always remain different kinds of canines. There will never be a canine evolving into something that will not be considered a canine. So as you can see, folks, Darwinian evolution is actually wrong, and the variations of species are actually due to environmental pressures, which what we call allopatric speciation and epigenetics. Now, if you don't believe me, just look the species. No matter how big or changes the species really are, they always remain the same species of the same kind. For example, finches, they're still finches, despite the small or big evolutionary changes. Now, if you look at the evolution of sticklebacks, you can see that they're still fishes. They're not amphibians or anything. There are many examples in nature that shows variations of species possessing the same genus. For example, if you look at the owls from Canada and one from Mexico, you can see that they're actually two different species, but they share something common. They're both owls. Evolutionists claim that brand new genetic information is the result of gene duplication to create brand new species. Now, there is actually a problem with that. Gene duplication itself does not create new information. In order for gene duplication to create additional genetic information, it will have to cross this process called neofunctionalization, which is basically crossing point mutations and surviving natural selection. Now, another problem with gene duplication is that natural selection uses nearly all of those duplicates as backups and eventually deletes them through deleteful mutations. There were many genetic studies showing that these gene duplicates actually result into pseudogenes. It is extremely rare to find a gene duplicate that is actually useful for Darwinian evolution. Now, another process that evolutionists like to point out is polypoization, and it is when a chromosome completely duplicates into a new chromosome. Now, the problem with that is that such process is actually quite fatal to mammals and humans. The problem with polypoization, or the duplication of chromosomes, is that it actually results in abnormalities such as Down syndrome and and even death or deformalities. Now, the only polypoization that you will see in nature are plants and some invertebrates. These plants and invertebrates explain very well why there are many not variations but brand new plants in the plant's family. It also explains why some invertebrates are actually completely different invertebrates rather than being the same, because of the duplication of chromosome. Now, the problem with the duplication of chromosome or polypization, excuse me, I can't pronounce it right, is that it doesn't fit well with mammals and humans, because it is really a biohazard to life. So basically, polypization cannot really be considered an answer for the increase of genetic information for Darwinian evolution to occur. Natural selection and random conventional mutations and genetic drift actually don't increase genetic information either, but rather arranges them to create new variations within the same species. This is why when we look at the breed of dogs, they actually look quite different or somewhat different to their parents, and why there are variations of type of dogs. However, regardless how many types of dogs are there or how big or small the variety is, they all share one thing in common. They both are a genus of canine. And that is because of Allopatric Speciation. They subdivided from different geographical places and reproductive isolated means. So as you can see, folks, genetic drift and mutations don't really increase new genetic information, but rather arranges genetic information. Now, mutations, they're either neutral or harmful to life, but usually it is extremely rare to find a mutation that is beneficial to life. Because even if they do find a beneficial mutation, it might most likely be subjected to natural selection and eventually be deleted by deleteful mutations and eventually result into pseudogenes. The fact that mutations are really rare for beneficial purposes, it is quite reasonable to say that epigenetics is a much more reasonable theory for the variations that we see in life. Alright folks, well that's about it, and if you have any questions or concerns, please let me know in the comment section below. And Charles Darwin, I rest my case.